All right, guys. Let's start up here. So, on your warm-up, you had to make 3 different pairs of integers that make the below statement true. Here's the statement. What's an integer? First thing. What's an integer? Shay. It's a whole number and it's opposite. So if it's like positive 7, it's negative 7 too. So an integer is a whole number and it's opposite. So you had to use integers from the Math Fever game. Go ahead, share at your table. What were some of the pairs that you wrote down for your answer? Go.
Negative 2, 100.
There's one. So Ava said this one. Ava said negative 100 plus negative 200, Ellie. That could have been one answer. Isaac, what's another one? Or Isaacson. Negative 50 plus negative 250. That also equals negative 300. Both of these are integers from the Math Fever game. Good. Rayanne, one more.
Negative 100 plus negative 150.
Oh, wait. 100.
Oh, no.
There's one more combination. Negative 150 plus negative 150. That also equals negative 300. Okay?
50 plus negative 350.
Ooh, I could have done, yes, but on the Math Fever game, was there a 350 value? No. But that's good thinking though, Hudson. I like your thinking because that is a true statement, except it's not values from the Math Fever game. I would like you to talk to your partner about this one. Go. I love what you did in the beginning on that one. I like what you did too. So I was looking. I was looking at what Jillian did, and Jillian had this. I think I'm doing it right. As her first one. She got it right for 200, Eva, and then got it wrong for 200. So what did she just do?
She just canceled that.
By using opposites. Opposites are awesome because what does an opposite do to a number? Brings it back to 0. And 0 is a great number for us to add from. Okay, subtract from. It's really easy. So what Jillian did here, Jojo, she went opposites. That equals 0. Jacob, give me another, or Lucas, give me another opposite that I could have used here.
100.
Another opposite, back to 0. Marcus.
Another opposite?
Yep.
I did 150 plus 150.
150 plus negative 150.
Yes.
And then what do I have to do here? So you can see, by using opposites, how easy that problem can be. Okay? Or I can make it more challenging. So here's where I'm going with that whole opposites, Jojo, is that being able to find 0 is a really important concept in algebra when you go to balancing sides of the equations. So and you're doing this. So you guys are already learning parts of algebra. Today, make sure you can get into your pre-algebra Google Classroom account, Hudson. Because let's say I forgot what the homework was. Where can I go, Ellie? Google Count, right? Go to the Google Classroom. It's going to show you what it is. Let's say I missed school, Tanner. What can I do?
Go on there and watch your YouTube video.
What?
Go to the Google Classroom.
You all have an account. Everyone has an account now, and everyone's been invited. So, Wyoming, if you forget, where do you go? Google Classroom. If you're not in school, Clover, where do you go? Google Classroom. Okay. If I need help from there, can I go to the YouTube channel?
Yes.
Yep, I can. If I need help from there. So, you guys, I make a big deal of this because I'm going to be holding you all accountable today.
Are you going to see if we can get
And hold on. Because you have an option of when to do your math homework. You can do it at home when you're by yourself, not hanging out with your friends, or you can do it at school instead of having lunch with your friends. That's your choice. You don't get to be like, well, I'm not going to do it. At home, you get more support than you will here at lunch for homework you haven't done. I had 2 students who came in this morning, 7:30. They showed up on the bus. They were down here. You know what they were doing? Their homework. That's being proactive. They're being really smart about it because both of them are like, I want to eat lunch with my friends. I was like, awesome. Do you need help? And they didn't need any help. They read the problems. They did. Boop, they were out of here in like 5 minutes. So, be proactive. Stay on top of your homework, guys. And grades, I've been posting them. So your grades are pretty updated. Some of you, right, over the weekend, you didn't show me homework on Thursday. So the grade shows it's a 2 out of 4 instead of a 4 out of 4. Okay, so make sure you check your grades. You get 2 points for every night you do homework. Okay.
Mr. Brown, do you, just to help us with
Yeah.
feedback, are you still posting it as one whole grade for the week?
One whole grade.
So it's up to, normally be up to 8 points for the week?
Yeah. This week will be 8 points for your homework. Okay? So if you get a 6 out of 8, that means you missed the homework. And it's your job to make sure you know which homework that is. I have it. You can come, you can ask me, but most of the time I'll say, open your planner. Which homework didn't you not do? That's my response because I'm doing my job, which is check it off, post it, check it, teach to it. Your job is to keep track of it and do it. So if you haven't been keeping track of it, Joey, that's where it gets hard. Then you have to figure out like, okay, what homework am I missing? Today we're talking about I can use a number line, which we talked about last week, so I don't need to talk about that. But this next piece, to compare 2 rational numbers. What's a rational number? We know what an integer is, right? That's a number and its opposite. Shay made that very clear at the beginning. So what's a rational number? Talk to your tables. I want to see if I can. What's a rational number? Do we know? Rational number? Not sure?
Is it like a whole number? What's rational?
Whoa. Whoa, Chad. So, Chad nailed it. Chad nailed it. Chad said, I think it's a whole number with a fraction. Yeah. So, it could be 7 divided by 2. That's a rational number. It could be this, 6 divided by 3. This is a rational number. What is that number? 2. But that's 2 represented as a rational number. Okay? A rational number is anything divided by something else. It's shown that way. So that's what we're doing. We're comparing numbers like 7/2, Ellie, to 6/3. We're going to be comparing numbers like that. But they're not just going to be positive, Ellie. What do you think they're going to be as well? Negative. Okay. Today, please go ahead. I'm totally satisfied with your homework. Put this in front of you. We're going to take some notes. You can close your have your notes in front of you for today. You put your warm-up away and get your notes out in front of you. Jojo, you got your notes? Sweet, man. I like what Marcus is doing. He's putting away his warm-up. This homework wants to go in your homework section.
Okay.
And your warm-up wants to go where it belongs. Jillian's putting away her warm-up. Okay. So we're talking about this today. We're talking about comparing rational numbers. So here's the thing, Tanner. We're going to compare them by extending the number line. We know what a number line is. So my first question is, what happens to values when we move left? So when we move, darn, what's going on? Oh yeah, there it is. When we move left, what happens? Talk to your tables.
Turns into a negative.
Witten, what happens when I move left on the number line?
You go to the positives and it makes more room. Sorry, you go to the negatives and it makes more room for the positives.
All right, so when I move left, do numbers get bigger in value or smaller? Smaller. Okay, so I want you to write right above that. Smaller in value. So when we move that way, numbers get smaller in value. How does that happen? By using operations. How can I make a number smaller? What's one way? Subtracting what? A positive. So I want you, above that, I want you to write smaller in value. One way, subtracting a, whoops, I'm going to make that a G, subtracting a positive. That's going to give us a smaller value. Eli, you writing down these notes? Okay. So subtracting a positive will give you a smaller value. What else will give you a smaller value? It's almost like subtracting a positive. Witten. Adding a negative. This will also make us move left on a number line. So subtracting a positive is just like adding a negative. So both of those, we're going to move left and our value is going to get smaller. So what about this second question? What about when I move right? Talk your tables. Greater. So I was listening to Marcus. He was saying greater in value. Numbers are going to increase. They're going to get greater, become greater. And on top of that, we know one way to do that is by adding a positive. When we add positives, numbers get greater in value. They increase in value. So, is there another way? Subtract what? So when we subtract a negative, that is the same as adding a positive. Numbers increase in value when we subtract a negative, Jojo. We learned this when we were playing the game the other day, remember? Okay. So here are the two things that we're going to be using today when comparing these rational numbers, Eli. Okay, we're going to need to know this, and we're going to need to know that. So we already talked about this, but I want you to write your answer below. What is the sum of a number and its opposite? And give me an example. Go. Give me an example to this. What is the sum of a number and its opposite? Like 5 plus negative 5. What does that equal? And how about negative 8 plus 8? What does that equal? Go.
Can I go into it myself?
Not yet. You can do it. Just do it at the end. I'm glad you brought it. You can always use mine too in here. Yeah, no. Go and use mine. So Lucas, what do we get for our values here? What is the sum of a number and its opposite? Here I have a number 5 and I have its opposite negative 5.
So the answer would be 0.
Boom! This is what we talked about in the warm-up. That any number and its opposite. So I'm gonna just draw a number line just to be clear. Yeah, I would like you guys take these notes. Whatever I take, you take. This is your note time. So I have negative 5 is right here. Positive 5 is right here. You can see this is 5 spaces away. And that is 5 spaces away. That's why one cancels out the other, because they're both 5 spaces from 0. So this last one, it says, how is a number and its opposite related? How are they related? I just explained. How are they related? Al, how are they related?
They're opposite.
But what does it mean to be an opposite? Ooh.
Opposite.
Clover?
They're both the same distance from 0.
Boom. Write it down. So, how is a number and its opposite related? They are same distance from 0. And so I want you to circle this word called absolute value. So you see that word I circled, or words, absolute value? This is the distance to 0. We call it absolute value. How far something is from 0, okay, and I want you to write this down, Jillian, is what we call absolute value. So negative 5 has an absolute value of 5 because it is 5 spaces from 0. Positive 5 has a value of 5 in absolute value terms because it is 5 spaces from 0. So go ahead, turn your paper over. So now that we got the basics down, we can start looking at comparing these rational numbers. Here I have an inequality. Ellie, what does this inequality say? X is greater. What's this line mean? What? Not bad thinking. But it doesn't mean divided by. Chad? Okay, that's this, right? That's the greater than symbol. What's that line? That means equal to. So, this means X is greater than or equal to 8. That's what that means. You guys have never seen the line underneath, huh? Maybe you have, maybe you haven't. But, ready? So that's what it means. It means X is greater than or equal to 8. Tell me, what's one value X could be? Talk to your tables and explain why. Go. Oh, why is it doing this all of a sudden? So if you could go ahead, make your number line. Please go ahead and make the number line. I am making my number line with a scale of 2. So I know in between it's just a scale of 1. And I was listening to Hudson say, hey, if I put 8 in here, 8 is greater than or equal to 8. 8 works. It does, because 8 is equal to 8. So I can go to the 8, and I'm going to put a circle. And I'm going to fill in the circle because it is equal to. 8 can be equal to 8, right, Tanner? Emma, does that make sense? That 8 can be equal to 8, and so I'm going to fill the circle in. Because if you notice, the circle means to include. This means it includes 8. And then 8 is greater than 8. So if I go back to this, where it says x is greater than 8, which direction would be greater than 8? Do I go right or left? Right. So this is where I make an arrow, and it goes to the right. That means any number. 10. 20. What about 8.5? Would 8.5 work here?
Yes.
Rayanne, would 8.5 work? Yeah. 8.5 would work. This is what I want you guys to do. Now you know that this means to include. That means 8 would work. If it's just a circle, not a dot, it means it doesn't include. Now that you know that, try this one. Try to graph it using the same kind of scale. I want you to graph that one with your table. Go. Work as a group.
First one. It says
What do you got?
Less than negative 8. I'm so confused. I thought your 2 was a 7.
No, it's a 2. Go ahead, get the scale. What kind of scale? You can use the same scale I used above.
That?
Talk about it. Nice scale, Jojo.
X plus 3.
Less than X. So
Interesting.
You want to start with the number?
I also have a question. So, do you want me to come into lunch to turn this in?
Yeah. Right at the end of class will be fun. Okay, so let's go ahead. Let's look at this. All right. So here's our inequality. Ava, so our inequality says this.
Yep.
Olivia, it says negative 7 is less than x. So, does this work? Negative 7 less than negative 7? No. That doesn't work because it's not equal to, right? So because that doesn't work, I'm going to go to negative 7 and I'm going to put an open dot. An open circle. Because that means it does not include negative 7. Because that's not true. Negative 7 is not less than negative 7. They're equal.
Yep.
So, because it doesn't include that, I have that open dot. Now this is the second part of this question here. X. It says x has to be greater than negative 7. Which way is greater than negative 7? Is it right or left?
Left.
Right. This is greater. Any number that way. 1 is greater than negative 7. 1.5 is greater. So you want to have your arrow going to the right because x is greater than negative 7. Yeah. So you want your arrow going to the right because that way is greater. So this is what I would like you to do. I want you to work with your partners. See if you can't figure out the last one. This is the hard one. Go.
this one has to be less than negative 3.
I already figured
Depends on when you hit the circle situation. What does it say?
Wait. X plus 3. Negative 6. Negative 6 plus 3. That would be
That'd be
3 at the end. Negative 3, that's less than negative 2.
No, it'd be
That's less than negative 2. That would work. That would work. I like your thinking there. So you figured out one number, Marcus, but our job is to figure out all the numbers that x can be. So look, x can be any number except for negative 7, right? It can be negative 6.99999 in any number that way. So, ooh. So let's go ahead. Let's look up here for a sec. So I'm going to go off from what I heard in two groups, Rayanne. Eva, you want to follow along here because this is a difficult problem. So here I'm saying this number, x plus 3, this is a number. I don't know what it is, but x plus 3 is less than negative 2. So I like to do this. What can x be to be equal to negative 2? Gavin. 5. Good. So I'm going to go ahead and make my number line. Negative 2, negative 4, negative 6, negative 10. So this is what Gavin just did. Olivia, he said, okay, here's negative 3, here's positive 3, here's negative 2. How far is it from 3 to 2, negative 2? 1, 2, 3, 4, 5. And because we're going left, it's a negative 5. So he says this. He says negative 5 plus 3 equals negative 2. Are you ready? Now let's go back up. If I put negative 5 here, this is going to say negative 5 plus 3 is less than negative 2. Is that true, or does it equal negative 2? It equals. So there is no equal to sign here, so I go to negative 5, and I put an open circle. Because it can't be equal, Eli. It cannot be equal to negative 2. It has to be less than negative 2. So now I put it on negative 5. So my next question is, which way is less than negative 2? Which way? Left. This is less than. So that's what my graph would look like. It'd be on negative 5. It would be open because it cannot be negative 5. And because it's less than, it's going to the left. Today, your job. See the problem. Here's your job for today. You're going to work on, and you're going to do this on your notes. So you have little spots above, little spots below. Use all the space. You're going to do problems. Whoops. You're going to do problems A1, A2, A3, B1, B4, C1, C2. I had about 9 kids last class get to the E's.
Haven't we already started this?
Okay? Nope. This is new. It's on pages 12 and 13. Okay, so get going. Go to problem 1.2. And here are the problems you're going to do.
Can we do it on this?
Yep, do it on the notes that you just took.
Can we use just a line piece of paper if we have it?
Excuse me? I mean, I would use my notes. That's what the notes are for. So you can just look on the notes and help you support your thinking. So we're on pages 12 and 13. You do A1, A2, A3. Okay, so ready? So, yeah, A, so I would do this. This is how I write it. I go A, 1, -7, okay, and then A, and then the other one is B, which is what?
B would be -4.
So you want to do that with every single one of these. And then you want to tell me the opposite.
How do I tell you the opposite?
Well, what's the opposite of -7?
7?
+7. Still. What's the opposite of -4?
4?
Okay? You got to do it for A through E. Most I just got to put this out. Make sure you guys, if you get some answers, or you want to know if your answer's right, go check it. It's on the board, right? Can you guys point to me where I put the answers? Boom, right there. They're right there, so you can check your work at any moment, okay? Okay, let's think about this one.
And there are a lot of notes
So-
on the paper today. You guys can use notebook paper.
So here,
If you're like writing all over your
if you
paper.
put
and everything,
0.9,
it's
that means you can
use
fit
notebook
9
paper.
of these here. What do you think? How else might you break up that space? I could break it in half, but then that's not on the half. What's another size that you tend to see people break stuff into, other than half? Fourths. What would this be in fourths?
That's a good question. So, A is your number, B is your number.
So how many fourths would that be?
Write down what you can.
Well, think about it. Break that, take it, break out into fourths. So you got this space. So if you take this and break it into fourths, like you said, boom, right down. That's a better guess. I like that, Ava, 3/4. So 6 3/4.
for this one?
Yep. So now you want to state the opposites.
Yeah, but it says estimate, so would I just put 7? Or would
No, you keep it as that. That's perfect. That's a good estimation. Jojo.
Why would that be like this way?
Okay, so you got, wait. Negative 1, positive 1. Okay. Let's go to D. So here we have 4. There we have 6. What's that?
5.
Aha. So if that's 5, what's that?
I don't know. 4.
4 is here.
So you're supposed to write down what the numbers actually are. Oh. For some reason last year's had trouble these directions this year.
So if that's 4,
Here's no list.
that's 5. What's halfway?
I don't know.
What's
4 and a half.
Bam! Nice work. So this would be 4.5, and that would be negative 4.5. So ready? But I like what you did here. If this is 6, that's 8. What's the line?
6 and a half.
No, there's 6. Yeah, 7. So this is going to be less than 7. So what's a number less than 7?
7 and a half. 6. 6 and a half. I don't know.
So, I mean, you could do 6.5. 6.5 would be right in the middle, though.
6 and 3/4.
Boom. Good job. Okay, fix those. And then,
Okay, so
no, you had them all right. You just had that one. And then 7.
So thermometer, it's up and down.
And then you just want to make a thermometer.
Up or down, so like
hang on.
positive.
What do I?
Yeah, would you say?
5
No. What'd you say it was? There's 4.
4 and a half.
Yep,
4 and a
And it's
half.
just saying.
And negative 4.
you got it. Bingo.
And then negative.
And then,
6 and 3/4.
mm-hmm.
6 and
In place of falling temperature
And the opposite.
and
then you have to say, okay,
Bingo. Okay. So now you're just going to make a thermometer. And you're going to put these values on the thermometer. Now you want to kind of think about your scale a little bit for this.
like what are they? Why does it go from 0 to?
Yeah, that's just the values they wanted to put on the thermometer.
So I can make up like my own values.
Yeah. Okay. What question you want?
3.
Making the thermometer? Okay. Remember, you're putting these values on it. And a scale, there we go. That's pretty good. Really don't have much of a scale, but
Yeah, do I need to add one?
no, but that gives me an idea of where it could be.
Okay.
Okay? Which one you want, bud?
A1, because I was doing it on this paper, but I
Okay.
decided to use another
Okay.
paper.
So, A, what value is that?
Negative 7.
Okay, so write them down. Try to be quick. Yeah.
I don't know how to put it.
Yeah, this is a harder question, huh? Because you kind of have to figure out, like, a scale, kind of, for A3. So,
I was gonna put it like near the bottom of the thermometer. No,
Why?
it's the positive. So
yeah, because look how big the positive, and look, that's the smallest negative. So it should be a lot more on the positive side than the negative side, right?
yeah, so I'm gonna should I put it like right here?
Can I borrow this for a second? I just want to share this. This is awesome. No, it's awesome. It's awesome. Your thinking's great. Ah. Okay, can you guys look up on the board? Is it? All right, so. Oh, come on. So, it's starting to come back. There it goes. All right. This is, it's a little bit bright, huh? But I'm going to zoom in a little bit. Bingo. Marcus is making a Eli. This is pretty cool. His thinking is phenomenal here, Shay. So, his thinking was this. It says to make a thermometer in A3. He starts with this. And then he's like, wait a minute. Should 0 be in the middle of my thermometer? And this is what he says. He says, well, my biggest positive value on this thermometer has to be 115. My smallest is negative 32.7 or something.
Yeah.
So he's like, zero's not halfway in between. So he's already thinking like, nope. Should it be higher up or lower? Lower. So he was already getting ready to move his zero down here, so he has much more positive room and less negative because he needs more positive. Super smart. That's smart thinking. Okay, back to work. Yeah. Here are all the values you have to put on it. That's what you got to decide. There's no right answer here. But you know you got to put all these values on there, right? But we know zero shouldn't go in the middle. That wouldn't make much sense.
But I'm just what I do is
Sure, and then put zero in where you think it belongs. Perfect.
so like just start
For B, is this right?
Yes.
Plus Fahrenheit is 5.
Because,
Whoa!
yes, no, because, and it could be easy because you just write because positive 6 is 8 spaces away. Boom, done. Support your thinking, that's all you need. Yeah, that's another way to explain your thinking. Make a thermometer. Okay, and you want to put these values on. Thanks, guys. Good job on the thermometer. Works. You do have zero in the middle of yours, right? Well, because look, because here is 115 spaces. Here, there should be 100.
You feel more confident in your working on it?
See, it's just thinking about scale.
Is all the way down.
The scale's off, but you got the numbers in the right place. Just the scale. Does that make sense, Chad? Yeah. No, I don't.
Feel the other side. Look at
What number you want, 10? So if you're not sure where you check. Bam! Good.
we have another tissue box because the other one ran out. I have a really stuffy nose.
Keep going, Amy. Keep going.
Do you have any homework tonight?
You need to ask more questions, and I'm going to have you stay behind so we can get to 8th grade. Okay, guys. Yep. Please go ahead. Put away your learning for right now. I only keep yours out though. Please put your learning away. Naomi, you need to close out. But leave yours out. Please get your planners out. Here's your homework, guys. Whoops. Homework is number 11 on page 20. Here it is. Go ahead. Whoops. Go ahead and write it on September 3rd in math. Number 11. Number 11, page 20. Okay, exit ticket. You can use that, use it tomorrow. Give it to me tomorrow. Exit ticket is this. So get your exit ticket out.
Today is Tuesday.
Here's the exit ticket. Like it, Mark. Gavin's working really hard. Identify which number is farther from positive 2. Explain your thinking. Negative 7 halves or 8 halves. Well, what's 8 halves as a number?
4.
Yeah, so this is positive 4 as a integer. As a rational number, it can look as 8 halves. What about negative 7 halves? What's that as a number instead of a rational number? Yeah. Negative. Close. Negative 3 halves. So which one is further from from positive 2? Negative 3 halves or positive 4? Explain your thinking. You want to get your exit ticket out. Yeah, we've already moved on. Just saying, you got to be really on it in here. You don't have time, Ava. I'm trying to help you because I don't want you to miss this. Because remember, this is worth 4 points.
Can we draw a number?
A number line would explain your thinking. Great.
What's the 3.5?
Well, that is what this equals. This is a rational number,
Oh, okay.
right? Written in decimal form, it's negative 3.5. Because, not yet, no. This is what we're doing. We're comparing two rational numbers. We have a rational number here, rational number there. We're comparing which one's further from positive 2. You want to show me and explain your thinking.